Okay, so let us go to the next slide, team. We'll start with a quick introduction of the panelists today, and starting with the agenda. If we can go to the next slide, please. So the panel discussion today is on lithium-ion cells for EV trends and recommendations. We have a very strong panel today where we will be seeking their advice and inputs on various questions which usually the startup members have. And the objective would be to seek their wise opinions and inputs, how those can be addressed. So on that part, let me just start with the slides here, the introduction here. So we have Stephen Louis, who is CEO and CTO of NextCharge. Stephen holds MSc in electronics and has devoted his career helping customers with best available energy storage, conversion, management solutions in B2B environments. He has joined as CEO CTO of NextCharge, the joint venture between Europe's leading lithium-ion battery manufacturer, Leclanche, and India's largest battery manufacturer, Exide Industries. As you can see, basically in his previous executive positions, he has built an international experience in transport, utility, and industrial battery markets. The next panelist which we have today is Mr. Bhavani Shankar, Vice President Strategy Business Development from Lucas TVS. He has been leading an initiative of Lucas TVS in bringing the lithium-ion cell manufacturing to India. Recently, Lucas TVS has signed an agreement with 24M Technologies of USA to bring forth an innovative semi-solid technology to the regional markets. He has been associated with Lucas TVS Groups over 20 years, and during his career, he has led the sales and marketing function with leading automobile organizations in the area of industrial consumables, machine tools, forgings, and electrical components. Then we have, Voltrez Tech team today, Sunil and Prasid with us. They have been working from IIT. They're a startup which is actively, they are currently developing working prototypes of dendrite-free, ultra-safe lithium-ion battery cells for electric vehicles, including two-wheelers, three-wheelers, four-wheelers, and related application. The safety value proposition is an addition along with the energy density and cycle life of tier 1 cells available in the market today. And basically, they have created a lot of interesting technology samples, and they're poised to basically partner and go into the space in the direction. So this is Stephen, as you can see. Then we have Bhavani from Lucas TVS, Sunil and Prasid from Voltrez Tech, and Murata Madhav from Murata. Madhav is a friend, and he is basically working at Murata to enable technologies in Indian market.
Yeah, good afternoon, everyone. Thanks, and thanks for the invitation. Well, I think the introduction was already pretty complete, and to be exact, Exide Leclanche Energy is a joint venture company of the two companies you've mentioned. But the recent news that some of you might have seen about cell manufacturing, which is the next logical step, is a complete Exide initiative. It's a 100% Exide initiative. So officially, I can't tell you too much about it, apart from what, of course, has been already released in the public. Is the partnership with SVolt. SVolt is, I think, the world's 8th largest manufacturer of lithium-ion cells today, headquartered in China, and with very ambitious plans. They currently operate production capacity or under construction of 60 gigawatt hours, and they have plans to ramp it up further to 600 gigawatt hours. This is information that is public from SVolt. And here in India, we will be manufacturing cylindrical cells and prismatic cells with different chemistries, many different chemistries. That's what we will be doing.
First of all, thank you for this opportunity given. It's good to be a part of the eminent people here in the panel, and also so many people out here in the group. So I think the introduction has been quite complete, but all the same, maybe I can add a few more points to what has been said. So yes, I've been there in Lucas TVS for over 2 decades now. And in the last 2 years, I've been focused on bringing in some lithium-ion cell manufacturing to complement our product range. When we embarked into electric mobility, maybe about 3 years back, in the area of motors and controllers. And then further, to add to the portfolio, we've been looking for, an area in the area of EV domain, also in terms of storage. And that's where we came across this interesting technology, a semi-solid technology that has been offered by an MIT-based incumbent company called 24M, which is based out of Boston in the US. So this is, we came across that, and as you would know, we have publicly announced it that, so we have technical and service cooperation with them. And so we have this plant which is going to come up near Chennai. And so just in short, I would say that this is definitely an opportunity which is available for all of us in India, because the domain of lithium cells has been somewhere where we don't have that type of gigafactories in India, and we are very much behind when it comes to the globe. So this 24M technology is already increasingly adopted across the world. We have a facility in Japan, which has been brought up by Kyocera in Japan. And then as we speak, the last couple of months, GPAC, a part of a big Thailand group called PTT, has also adopted this technology and has put up a pilot plant, and they're going to go big. And there have been further announcements where FREYR in Europe has talked about a 43 gigawatt hour scale plant coming up in Norway with about 4 factories. And then, of course, I think you would have all heard about Volkswagen having also endorsed this technology, and they're going to come up with a setup in a plant in Europe, which will be more focused on the mobility side. So it's all very interesting for us, and we think that with this technology, we should be able to sort of leapfrog in this area of storage, lithium-ion, both for mobility as well as storage. So we'll talk more about it.
Hi, I'm Sunil Mehta, CEO and co-founder of Virya Batteries. As Ethan already mentioned that we have technology of ultra safety. One of the key things about our technology is it basically resides all on the anode side of the technology. So we are agnostic to whatever is the chemistry on the cathode side. So we have options of cells which are with NMC, with NCA, and also with LFP. It can also go with future technologies where the need for having the anode as dendrite free is very critical. So that is going to be one of our key going forward strategy, where we will, besides licensing, we will also be considering to do manufacturing of our own cells. And that's how we plan to take it forward. Maybe Prasid, you can add something more on the technology side, please.
Yeah, hi, this is Prasid. I'm the CTO and co-founder of Voltrez Tech. So I'll just add few points to what Sunil said. So our main focus on main expertise resides on 3 basic areas. The number 1 factor is the material. We use a special material to make ultra-safe lithium-ion battery cells. Our process is one of the key factors, and obviously the cell design, we make it. So we try to make it the minimum resistive path for the lithium-ion as well as the electron flow. So these are 3 basic areas where we basically focus on. And based on these 3 key areas, we make the battery ultra safe. Thank you.
So we will start with the discussion. As you can see, the topic is that lithium-ion cells for EVs, trends and recommendation from various panelists. We have a couple of points for the honored participants. I will start with first question first, and request in the same order, starting with Stephen, to present his views on the first question from our side, which is basically all our members and other participants are asking, which is basically what are the cell form factors, which cell form factors shall EV companies in automotive space should explore if there are certain preferences or certain guidelines which the participants of the panelists today would like to share. So I will request Stephen to share his views on the first question. Over to you, Stephen.
Yeah, thank you. EV companies in the automotive space, of course, is a very
This person is the CEO of Excite Leclerc. Excite.
I think someone should go on mute. The answer is difficult to give if you consider such a wide scope, because two-wheelers or three-wheelers or passenger vehicles or commercial vehicles may not be using the same form factors. So if I would have to answer for every market, then it's going to be a long meeting. I think two rules of thumb that I would like to share is that there has to be a healthy ratio between the size of the cell and the size of the pack. You can't make a pack with only a few cells. It wouldn't work very well. So you need to have a good ratio there. Like 100 cells or something like that is a very good ratio from cell to pack. That's one thing. That will also give you flexibility to add a little bit more or less capacity, subject to what the customer needs. And I think that rule is true across all markets. Secondly, if I think about passenger vehicles, which is an important market, probably the most important market to drive volume, which is what you need to bring the cost down, apart from two-wheelers, of course, is that there is a trend going, of course, to remove the module and even to remove the pack, you could say, with these cell-to-pack and cell-to-vehicle or cell-to-chassis or whatever you call it, principles. So if you look at that trend, where we're going more and more towards a battery that fits in the vehicle and is not removed during the life of the vehicle. If the vehicle is end of life, the battery is end of life and vice versa. Then you need to look for a cell that best fits that target of making the battery a structural element of the vehicle. So there are concepts in the market where you basically have for passenger vehicles the two rear wheels and the two front wheels, and they're basically bolted to the battery pack, and now you suddenly have a platform and you put the chairs and then the roof and all that on top of that. So if the battery pack becomes a structural element of the vehicle, which I do believe is the future, then that somewhat limits you to which are the best form factors. I believe that BYD was probably onto a very good technology to go into that direction with their long blade cell, but they have patented it and you will not get that from anyone else unless they can take a technology license. But that technology, in my view, is a very good technology to go towards that future.
So I think Stephen has so much of experience, and there's been so much of learning which I personally have taken from Stephen, because of his experience on both the battery as well as cell side. We are a little new to this area. We've been more focused on motors and controllers. But all the same, I think some of the fundamentals, what we have understood, and the way we think things are going forward, I will just share with you. One, what we have seen is, of course, typically all of us are aware. I think this difficult choice is always there between three formats. One which is cylindrical, the other which is prismatic, and of course, the other one, which is the pouch. And as all of us are aware, I think today, when you look at the conditions within India, we see that it's sort of, there's so much of cylindrical cells. Most of the applications are with cylindrical cells, and that always makes us to question, why is it so? And I think a couple of reasons, maybe as we have seen it, is that cylindrical cells have been always are most readily available and has been most commonly used across so many applications and for so many years. And we all know that Tesla also in these initial vehicles, all those electric vehicles have been launched with good cylindrical formats, very easy to manufacture. And of course, we have enough of a supply base when it comes to cylindrical cells. And also we believe that it is also a little bit more easier when it comes to the pack building, on the cylindrical cells. But then, yes, it also has its own drawbacks, like in the sense that the heat dissipation is a little difficult. We believe that's the experience which our own engineers have also seen. And also, because, in terms of the interconnections, the bus bar space and all is much less when compared to the other formats. So typically, when you look at the prismatic or the pouch formats, they are in order of the next is the prismatic or next is the pouch formats. In terms of energy density, these are the formats going forward which are more friendly when you want to go for higher and higher energy densities. And typically, more and more so today, more and more all these applications, be it mobility or be it storage, they are calling for a lot of higher and higher energy density or higher energy requirements are very much there. So then these formats get a little more used. Prismatic also, we see quite a lot of that in applications in India. Pouch, a little less frequently we see because it is a little more sophisticated in terms of manufacturing and serviceability. That's what we believe. That's why pouch, there are not too many players, but then yes, that is also getting popular. And so two very distinct advantages of these bigger prismatic or pouch formats. There are very few interconnections. And you can make it bigger, larger formats, and you can reduce the number of interconnections. That is one. And the other one is, of course, since they offer a larger area, the heat dissipation or the thermal taking out the heat is little more simpler when it comes to the prismatic or the pouch formats.
Thanks, Bhavani. Great inputs. Like Stephen, I think we have received some new learnings from your side also. Just to give inputs to the panelists here, because Micelio is involved with startups and emerging companies.
Okay.
In general, you have seen that there were drivetrains in India around 1,000 watts in medium speed and low speed two-wheeler application. In three-wheeler, you will on an average will find 4,000 to 6,000 watts in the L5 category, and then obviously in four-wheelers it goes up. Now the problem is that most of the startups or electric vehicle two-wheeler companies now are developing vehicles around 3 kilowatt nominal, and sometimes that is the peak is going up to 5 kilowatts, and that's where the cell form factor and how the battery pack is packed with respect to the space available in the two-wheeler, that question is arising, because till your vehicle performance was lower or low speed or medium speed, the battery capacity can be smaller. So now the question is troubled that can we look at either bigger diameter of cylindrical cells, or there is, for example, if you look at some traditional manufacturers, some of them are only using batteries which are having pouch cells because they're fine with lesser range, but they would like to have low cost and I would say safety in mind, so they are using LFP instead of NMC. And so these are some decision challenges which startups are facing.
We are actually quite relatively younger in this space, and I think the inputs that we have got from both the previous speakers have been much more from their experience and exposure in the industry. On our side, we are still struggling to figure out what is the form factor that we should be going towards manufacturing. And I think we can use the inputs in terms of using things like cylindrical and pouch initially, especially to address the smaller vehicles. So that is something that we feel that in the Indian conditions with the kind of thermal engineering required, those could be the good form factors to go with. Don't have much more to share on this, so unless Prasit, you can go ahead and share something on this aspect.
Yeah, in this area, one question always comes, that is, what is my electrical path? So if my electrical path is bigger, let's say for 8650 cell, my electrode size is bigger, and for a pouch cell, maybe my electrode size is smaller. In that point of view, pouch is a winner, and obviously other banks already said on this particular topic that area per ampere hour is another major factor over here. So if you see the 8650 area, it is quite smaller compared to pouch and prismatic. If we make pouch and prismatic in a smaller ampere hour size, so my heat distribution will be much more better. So it's always a challenge, and it's always a complex topics between what is my electrical path, how much I can reduce the electrical path, and what design I will go for so that maximum heat distribution can be possible. So it's always a challenge between these two questions. Thank you.
I think I would be very specific to lightweight electric vehicle applications, two-wheeler and three-wheeler. I think we should definitely categorize the battery space into two categories when it comes to lightweight electric mobility. One is where you are looking for the swapping, and second is when you are looking out for the fixed battery pack. When you are thinking of building a removable / swappable packs, weight is the constraint. And like Iten has highlighted that these days the two-wheeler and majorly two-wheeler OEMs are making 3000 watt motors. They need around 1.5 to 1.7 kilowatt at least deliverable energy to have range around 70-75 kilometers, right? Looking at those perspective that you need to be lighter and you also have to deliver 70-75 kilometer range, I think you have no brainer and you have to go with the cylindrical cell to achieve cobalt based cylindrical cells to achieve those kind of energy density numbers. But with going with selecting a cobalt based chemistry immediately raised the safety concern. We have seen many incidences on the road very frequently these in last 2-3 months, that there are a lot of fire and the hazard incidences on the road. So whether we can choose cylindrical form factor in LFP or not, I think LFP is right now around 160-165 watt hour per kg from CALB. But there are some manufacturers from China like Guan's One. What they are claiming that they have able to crack a lithium-ion LFP chemistry at 200 watt hour per kg. So now you are comparing LFP cylindrical versus cobalt-based cylindrical cells. In cobalt-based cylindrical cells, you definitely need to deploy some kind of thermal management / propagation protection. Either it could be PCM or some kind of other material which adds to the weight. And when you are using the LFP chemistry, you might not need those kind of element.
We will go back to Stephen for the second question. Stephen, over to you.
Yeah, thanks. I think that if your requirements annual volume is less than a couple of gigawatt hours, you can only choose an off-the-shelf product from an existing cell manufacturer. If your volume is higher, you can get a cell designed for your particular application, which, by the way, also has an impact on the previous question. So if you have gigawatt hour scale requirements, you can pick the form factor that best fits with you and the chemistry that best fits with you. and also tweak the chemistry and the cell design for your requirements. So if you don't have that volume yet, and I think for most markets in India, that's where we are, you have to work with an off-the-shelf product. And your challenge will therefore become, how do I find an existing off-the-shelf product that closely fits to what I need? And do I have more than one supplier for that same product to reduce the strategic dependency from a single supplier, if possible? Those are real challenges. Will those products meet the specific requirements of the Indian market is the second challenge, because I would say that globally it's the tropical climates like India, like Africa, like South America that have taken up electric transportation a little bit slower than other parts of the world. So the specific requirements that we have in India are more difficult to find a product for than more mature markets. Thirdly, and that will be my last one, I want to leave some for the others, is the stability of quality. If you have found a good product, it's a lot of effort, a big challenge to ensure that that product remains good for the life of your production, your product life, basically, your product life cycle. So that is definitely also a challenge. And you'll have to set up very good quality mechanisms to ensure that, because the true quality of a cell is only experienced as it ages and is being used. So you can be putting hundreds of thousands of vehicles in the market with bad cells, and it'll be maybe a year later before you find out. That is also why the largest recalls of all technologies in the world have been on batteries. When you go to a check-in at an airport, you don't see information about you should not take this or that onto the plane. You see about Samsung Note 7, and you see lithium-ion batteries all over the list. So safety of batteries and the consistency of that safety and that quality is definitely also a challenge.
So this is very great input, Stephen, from your side. I will now request Bhavani to go next and share his findings when he's interacting with vehicle manufacturers and other possible customers. What are the problem statements he would have seen, and what will be the general advice to the startups, when they're making up their mind what kind of cell they should order? So in future, if Lucas TV is manufacturing units and you would like to position those to these companies, so what will be your inputs there? Over to you. You are on mute, Bhavani.
Yeah, you can hear me, right? So thank you, Hiten. And so I think a very relevant question, a question which we have been also battling over the last year or two. And just to hear earlier Stephen talking about it, I tend to agree that this is a little bit of a volume game, no doubt. So we really need some very large volumes to be competitive in this space. We already know that there are the big giants who have several gigawatt hours, and so they are able to really, give a little bit of a competitive price. But all the same, just to typically when you look at EV companies, when they have to decide cells for their batteries, I would say to start with, I will answer this question in two parts. One is with reference to what I have found, are the broad aspects which everybody looks for, which I think also most of us are aware. One is, of course, the 5 factors, if you were to look at it, I just put it into these points. One is, of course, the driving range. I think we heard it from the earlier speakers also, this prime and very important. Everybody talks about how far this will take the vehicle within one charge. That's one. And other is, of course, the limiting factor where, see, battery is of course a very high component within the vehicle, but overall itself, the challenge for the EV is the high cost. So unless there is something to be done on the cell cost, on the battery cost, this is a fact. This is something where for the EV itself to get penetrated in a very big way, it will be a very big challenge. So there's a high cost, and then there is a battery cost, and also the other is also about the charging time. Everybody talks about it. Every day we see in the newspapers and things like that. We find innovations coming around how quickly we could charge. Okay. How within 15 minutes, within 5 minutes, not necessarily in those hours or overnight charging. So, but all this will also have its other flip side, because when you go for such type of high charge rates and high discharge rates and things like that, naturally it will have a effect on the overall cycle life.
So what we gathered, one of the major challenge that these, especially the startups and smaller companies are facing is getting the supplies from the tier 1 cell manufacturers. And any cells that are coming from other than the tier 1, then there is a issue on the quality aspect. Consistency and quality are a major concern areas for any cells that come from other than the tier 1 manufacturer. Now, even when they get the cells from the tier 1 manufacturers, there are concerns in terms of which grade of those cells that they are getting, because apparently globally the grade 1 cells seem to be going to the Western markets. So those are some of the major concerns on the quality aspects that we can see. The second thing is there is issues in terms of the thermal engineering of the battery packs today. So with the cost considerations in mind, majority of the people are not doing any kind of thermal engineering in their battery packs, and that is leading to a lot of risk factors in terms of mishaps with the battery packs. So these are a couple of things that I would say are one of the major challenges, which hopefully with local cell manufacturing coming up and all will get addressed in due course of time. Yeah, Prasit, you want to add something?
Yeah, so in terms of our case, what we have done is we have taken a challenge with this, and we are first starting with NMC 622 chemistry, and we have opened up 2 options for all of the customers. And I've seen that people are accepting the pouch option as well as cylindrical option, and we are open to both of them.
I think with a startup and the mid-sized company, the main problem is the volume. And when you don't have a sizable volume, you cannot just get the latest trend or the technology from the market. Like a startup cannot easily get an NMC 811 or NMCA, which is recent developments from any A-grade supplier, right? So I think a startup and a mid-sized company should rather focus on a battery design where they can easily adapt their battery pack from 18650 to 2170 to 3270 or in the same cylindrical form factor. They don't have to change their entire battery design to adapt to new chemistries and the form factor if they are starting, if they start getting it from time to time. And secondly, they should also focus, suppose there is a company which is building swapping station with swappable battery packs, and they have used a cell, let's say A, for their 10,000 battery pack, and after there is a great breakthrough and they now getting a new type of cell which is chemistry B, which is more advanced, stable and economical. Now they have to push the battery pack which is made of a B type of cell, and the situation is on the ground is going to happen that you have A battery pack as well as B battery pack. So how these two battery packs are going to work together inside a powertrain if you are having working on a multiple battery pack. So those kind of technology development a startup and mid-sized company should focus rather than running behind the chemistries and the recent development we have seen that Gogoro started with 1.3 kilowatt hour. They have updated it to 1.7. In 2013, they were 1.3. In 2017, they updated it to 1.7. And both battery were existing in the network. And a customer can easily get 1.3 and combination of 1.3 and 1.7, and their powertrain was able to run the vehicle without degrading the performance. And now recently we have seen that they are about to launch a pilot of solid state battery, which is 2.5 kilowatt hour. So you think that inside the network you have 1.3, 1.7 and 2.5 within the same form factor, and all those has to work with one customer. So the startup should focus on the technology, how they can manage different cell chemistry simultaneously inside the application, and their pack design should be so adaptive that they can transition from one cylindrical size 18650 to 2170 to any cylindrical form factor without changing a lot in their manufacturing process and the quality management and all those things.
The advice to startups that they can basically target and pay attention to largely using what is available off shelf to start with. And I can add to that, if there is mutual agreement on certain, I would say, design principles that will help all sides which are involved, and both battery design, battery manufacturing, and obviously using those batteries to integrate with the vehicles. Now we will go to the last question, and again we will do a round robin and ask all the panelists to provide their inputs. Last question is, what is your suggestions to improve the safety of the battery design? Now, many of you have cells, your own cells, and you might be exploring, to be given to give those cells to certain vehicle manufacturers, or you can be supplying the entire battery pack to these manufacturers. So, in this variety of combinations exist. So, what are your advices as far as safety of battery design is concerned? And again, I will request Stephen to start. Over to you, Stephen.
Yeah. I would like to start with the assembly and production of battery packs. We are currently in full production of battery packs, of low voltage and high voltage battery packs. And manufacturing those batteries safely is a massive challenge. People are not used to it, and the biggest problem is that cells do not have an on-off switch. They are always on when we receive them, and they are extremely powerful. You can have a simple piece of jewelry or an unisolated tool that creates a short circuit and heats up to hundreds of degrees of Celsius within a second. So managing those risks on the production floor are also, I would say, part of the design, but definitely most of all your process. Coming to the design itself, lithium-ion cells, as we all know, have the risk of thermal runaway. I think from that point of view, batteries are relatively safer than a fuel tank. A fuel tank can explode, and that's a very unpleasant experience. But a battery pack typically doesn't explode in the sense that it suddenly goes kaboom and flies all over the place. That's very unusual. It does catch fire, and of course that has devastating results, not only in the transportation industry, but also in the stationary. Imagine that you're sleeping and you have a residential storage battery or an electric cycle which is charging overnight, and if that battery catches fire, you may die in your sleep. That is not good. So I see the risks more differently than in the traditional way of a vehicle catching fire. Speaking of that, we have developed technologies and have them ARAI approved that give an early warning to the driver of a vehicle that a thermal event is about to happen. And we can predict it as early as half an hour in advance, thanks to our technology, which we are now patenting. So more than half an hour in advance before a thermal runaway happens, we already see it through our sensor network. And we can then inform the driver to park the vehicle in a safe place, evacuate any travelers in the vehicle, and of course himself. We cannot stop the thermal event from happening because that may be based on something that's happened already in the cell, but at least we can inform people.
Yeah, I think Stephen has already summed up some portion of it very beautifully. Like, I think the more and more now we are seeing people getting more conscious about the need for safety, especially when it comes to these batteries. One thing which is very obvious is, when it comes to these vehicles, there are a lot of these vehicle thermal runaway incidents or fires and things like that, which even take place even in the case of the IC engines, right? But those, are something which doesn't come readily to our notice. But when it comes to batteries, especially lithium-ion batteries, I think people are very, very conscious about it. Maybe that earlier days of Samsung Note and things like that. So that has been fresh in our mind. When we talk of lithium, we talk about thermal runaway incidents and fires and so on. So I think why we would say lithium-ion batteries would be very dangerous is, of course, if they are actually not designed very well, that is one, or if they're also not very used properly, or we would say even say some sort of an abuse. When these things are there, I think here we have a situation of little dangerous situation where we cannot compromise on the safety aspects. So, so many of these aspects. So for the area of safety, I think more and more there are, as told by Stephen earlier, there are regulations which are coming and new standards are coming up in India, which are very relevant to our type of conditions, our type of environment conditions. These are coming up. And if you look at it, we need to be all the materials which we use in the case of they say in the cell manufacture, for instance, we are more associated on the cell. So we see like cathodes, the anodes, the separators, the electrolytes. These are all very, very important elements where we need to make sure that we use the right materials. Quality aspects are so important, and the type of checks which need to be there across the process. I mean, I also heard while we were discussing with several of our consultants, even though we have been there ourselves in the auto industry for over 4 decades, it's much, much more than a typical auto type of industry when it comes to the quality aspects or the quality checks that would need to be in these lines. Most of these lines are automated, but all the same, the number of checkpoints on quality are very huge.
So basically, as already Stefan and Vani have already mentioned about several of the external factors that play a role in terms of leading to thermal runaways, be it the engineering part or be it the electrical part, maybe due to causes like accidents and various other things that can happen that could lead to fires. But one of the major things in thermal runaway is in the conditions when there are spontaneous fires, which are not connected at all to any kind of external abuse. Now, one of the factors that Bhavani did mention about it is foreign particle debris inside the cell. So these are kind of categorized under the category of manufacturing defects. So either be that as a foreign metallic particle left inside the cell during manufacturing, or it could be that the separator is not mounted properly, or the tab welding is not done adequately. So these are some of the manufacturing defects that lead to such fires. Besides this, the other major inherent issue with respect to the thermal runaways or fires due to the cell's internal mechanism is the formation of dendrites. Now we know that dendrite formation happens during charging when the lithium ions are traveling to the anode from the cathode. And when they keep growing, they lead to a couple of issues, right? One, if they grow large enough where they end up piercing the separator and shorting between the anode and cathode, it will immediately lead to a rise in temperature and lead to the thermal runaway situation. The other factors, even if it is not leading to this kind of factors, it will lead to many times early failures of cells due to side reactions that dendrite has inside the cell. So what we have done with our technology is we are preventing the lithium plating itself, which is the starting point where the dendrite formation starts. So by eliminating the lithium plating itself, we are ensuring that there is no dendrite formation, and thereby a major part of inherent safety that is needed in the battery pack is brought into these battery cells with our technology. Yeah, Prasid, you would like to add?
Yes, well, I'll talk from a general perspective. Sunil has already told about the dendrite part. So there, from the technology perspective, there are basically three questions we need to address. When we are going for a cell design, the first question is how well my current is distributed inside the cell, inside the material. The second question is how well my lithium is distributed inside the cell, inside the material. And the third question is how much heat is coming out while we are charging and discharging. And is that heat coming out properly out of my cell, or it is doing some side reactions? So if I unable to address the first two problems, it will lead to a dendritic situation where dendrite formation will happen, and later on it will do a short circuit, internal short circuit, and it can lead to fire. The third question is all about the heating. So if my heat generated inside the cell is not coming out, then it can go to a stage 1, stage 2, and stage 3 of thermal runaway, and it will blast a cell. So from a material perspective, obviously there is some improvement happening all over the world. When I can see the LFP is coming out in a very good shape, even NMC 811 is also coming as a safer option, but we have this a very nascent stage. Compared to the cathode, if I go to the separator side, and separator is also going very good, and it is going higher in temperature sustainability. Even today's date, we can get around 300 degrees centigrade or more stable separator with some level of coating on top of it. From the electrolyte perspective, the moment we are going for a semi-solid kind of electrolyte with addition of some additional electrolyte additive, we can make the electrolyte safer as well.
Moving forward, the next part of our session today. So we have Voltrez Tech, formerly known as Virya Batteries, one of our prominent members, BTech members, which are working on multiple technologies, largely lithium-ion cells, and they have also taken part in the panel discussion. So now I will request Sunil and Prasid to kindly share their screen and walk us through the various products which they have developed and in moving in the direction.
Okay. Yeah, and okay. So we are now Voltrez Tech. Formerly we were Virya Batteries. Very recently the name has been changed, and we have a patented technology of an ultra-safe lithium-ion battery cells. This is probably one of the earliest in the world with this kind of a technology. Now, to give a brief demo, we are making currently the pouch type cells because of the facility that we have available at IIT Bombay, where we do the cell production. And this is a video showing we use our cells to make battery pack, and we keep testing them on a two-wheeler right now. Next stage, we'll be also planning on testing it on a 3-wheeler as well as on a 4-wheeler. This is our co-founder, Professor Sagar Mitra himself, riding the 2-wheeler, by the way. So now what is unique basically in our product? Everybody makes cells, right? So why we are unique? So as you can see in this video, we have all seen this video many times in the past as well. Fires are continuously happening, spontaneous fires especially happening in these EVs. Even recently there was some incident in India also where these kind of fires have been circulating on the WhatsApp. Now, these kind of incidents are happening with no external abuse conditions, and dendrite could be one of the causes. Besides, other causes could be like manufacturing defects, etc. Now, most of you already know, but just to briefly recap, dendrite formation basically starts when lithium ion travel from the cathode to the anode, and some of those ions deposit on the surface of the anode, turning into lithium metal called lithium plating. Once a plated lithium is available, more lithium ions get attracted due to kinetic factors, and it grows into this tree-like structure, which ends up shorting between anode and cathode and creating shorts. Now, all commercial available cells today are susceptible to dendrite formation, and research has been going on for decades to solve this problem. This is a video of a tier 1 cell manufacturer cell where a small area of exposure is done and it immediately catches fire. This confirms the presence of lithium metal inside the cell, because lithium metal reacts with humidity in the atmosphere and immediately catches fire. Some of the validations that we have been doing are where we have been exposing the anodes of commercial cell and also anodes of our cells. On the left and right, the images you see are also made of SEM high magnification images, where we can also see whether there is a lithium metal deposition or dendritic formation available on the surface or not. So these are some of the ways, and when we expose the electrodes, you can see what happens. The commercial anode immediately catches fire within 25 minutes, whereas in our case, we kept it on for more than 6 minutes and nothing had happened, and we just closed the test because it was not doing anything in terms of catching fire. This is another video where we destructively tested an abusively charged discharges cell at 3C charging rate, and even after a large area of exposure, you can see that it demonstrates a very safe behavior. Even the balance of the cell is still continuing powering the LED light. This is just to show you the production line facility that we have at IIT Bombay, where we are doing the cell production. This is the coating line where we are making the electrodes. This is the heating chamber where the coated electrode is being dried. And this is where the final electrode comes out of the coating line. These are the pouch stacking automated line where the electrodes are stacked together into a pouch format. And these are some of the cells that we have been making in this facility and doing testing and validation. And we should be out in the market in hopefully in the next 6 to 8 months' time. So in terms of product performance, currently we have reached the cycle life of around 1200 at a 1C charge discharge rate. And we are in the process of increasing the repeatability of this cell manufacturing before we go into large-scale industrial production. So in terms of competitive positioning, energy density and cycle life point of view, we will be equivalent to the tier 1 cell manufacturers such as Panasonic, LG Chem, Samsung, etc. But on the fire risk and on the safety aspect, we will be far superior. So this is where we will be offering the benefit to our customers who will want to use our cells in their battery packs. And in terms of roadmap, currently we are making NCM based cells which are at 622 level. Going forward, we'll be having more lithium rich, nickel rich NCM, which is 811 and other combinations. And we will also be having LFP cells to complement for higher stability purposes. Thank you.
Thanks, Sunil. That was very interesting, I would say, presentation from your side. And the other product demo from Comsol, unfortunately, the team is not here today. So we will basically close our digital side of the event and proceed towards the networking event for the members who are present here in person. And before we close, if there are any questions to Virya Battery team, please turn on your mics and ask before we conclude.
Yeah, hi, Sujoy from Electron Engineering Bangalore. Thank you to the Virya team for an amazing presentation. And I'm really glad to see IIT Bombay's the startup come out. So I just wanted to ask about the cycle life. Like, as I understand that most of the reduction in cycle life happens due to lithium being dropped out, SEI layer being thicker, etc., etc. So isn't the theoretical cycle life of your system much higher than what is commercially available? Can you please comment on that?
Prasid, do you want to take this?
Yeah, so theoretically, obviously, it will be higher cycle life, and we are slowly progressing towards it. And currently, we are projected around 1200, and we'll be targeting more than 3000 cycle life with this chemistry. And along with the cathode chemistry progresses, it will be much more higher than that. So obviously, dendrite is a blockage on top of the SEI and all these things. Since we have removed it, so theoretically, obviously, we'll get more cycle life. Yeah, thank you.
Thank you. Look forward to that.
Yeah.
Great. If there are any more questions, the floor is open. Great. Okay. So thanks, everyone. Thanks all the panelists for today's wonderful session today. Usually the community events are quite hands-on, and we would like to that in future when we are together, we are doing offline sessions which are far more interactive. When we're doing hybrid or online, there are confusions, and many discussions are wonderful. Many discussions still can improve. So next time we will make sure that many of us are in person in a larger space. We can sit together, do brainstorming on various matters. And today was a wonderful session where we can learn from all the honored guests and learned panelists. So I also appreciate and thank all of the members, senior leaders who could attend the session today, both virtually and in person. And hopefully in coming sessions of our monthly member meetup, we can choose more productive topics and burning issues which can help all of us in that direction. We will proceed to our offline networking session, and we will close the virtual session now. Thanks for your participation. Have a nice day.